Tray cable, often referred to as TC cable, appears to be used in residential work as opposed to service entrance cable, and even in place of ROMICs in sizes larger than number 4. This includes panel feeders and services before and after the first point of disconnect. The understanding is that it should only be used in a cable tray or underground as part of a cable tray installation. However, it is being used even though it is more difficult to pull, bend, strip, and properly identify conductors, which are numbered instead of color-coded. It is observed that TC cable is often cheaper than service entrance cable. There are several reasons for the observed usage of TC cable in Arkansas. Firstly, cost. TC cable is less expensive than service entrance cable. Secondly, availability. TC cable is readily available from local electrical distributors in Arkansas. Thirdly, perception of durability. Some electricians might believe that TC cable is more durable than other types of electrical cable. However, there are concerns with using TC cable. Firstly, code compliance. TC cable is not permitted for use in residential applications without being installed in a cable tray. Secondly, installation challenges. TC cable is more difficult to pull, bend, strip, and identify than other types of electrical cable. Thirdly, grounding issues. TC cable must be properly grounded to ensure safety. The trend of using TC cable in residential applications where it is not permitted by code is likely due to its low cost and ready availability. Problems with using TC cable in non-compliant applications can lead to electrical fires, injury or death, and code violations. Firstly, electrical fires. Improper grounding or overcurrent protection can cause electrical fires. Secondly, injury or death. Faulty electrical systems can result in injury or death. Thirdly, code violations. Using TC cable against code can lead to building permit denials or fines. It is strongly recommended to adhere to electrical codes and use appropriate types of electrical cable for specific applications. While TC cable may be cheaper and easier to obtain, it is not suitable for use in residential settings without proper cable tray installation. When considering electrical work, remember the National Electrical Code, often abbreviated as NEC, is a comprehensive set of standards and guidelines for safe electrical installations. Adhering to the NEC is crucial for protecting people and property from electrical hazards. The NEC addresses various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. It's important to consult the latest edition of the NEC in local electrical codes to ensure compliance with all applicable requirements. One area covered is cable types. The NEC specifies approved cable types for different applications based on factors such as voltage, amperage, environmental conditions, and installation methods. Using the correct cable type is essential for preventing overheating, insulation breakdown, and other potential hazards. The NEC also outlines requirements for installing cables, including proper support, protection from physical damage, and separation from other systems. These requirements help ensure the long-term reliability and safety of electrical installations. Grounding and bonding are critical components of electrical safety. The NEC provides detailed requirements for grounding electrical systems to minimize the risk of electric shock and equipment damage. Grounding creates a low impedance path for fault currents to flow back to the source, allowing overcurrent protective devices to trip and de-energize the circuit. Overcurrent protection, such as circuit breakers and fuses, is designed to protect electrical circuits and equipment from excessive current flow. The NEC specifies the appropriate size and type of overcurrent protection for different circuits based on the ampacity of the conductors and the characteristics of the connected load. Proper overcurrent protection helps prevent overheating, fires, and equipment damage. Electrical inspections are conducted to verify that electrical installations comply with the NEC and other applicable codes. Inspections are typically performed by qualified electrical inspectors who are familiar with the code requirements. Passing an electrical inspection is essential for ensuring the safety and legality of electrical installations. When performing electrical work, It is essential to follow safe work practices to prevent electrical shock, burns, and other injuries. Safe work practices include energizing circuits before working on them, using appropriate personal protective equipment, and following lockout/tagout procedures. Electrical work should only be performed by qualified and licensed electricians who have the necessary knowledge, skills, and experience to perform the work safely and in accordance with NEC. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. When dealing with residential wiring, several common types of cable are encountered. Non-metallic sheath cable, often referred to as NM cable or Romex, is commonly used for branch circuits in residential buildings. NM cable consists of 2 or more insulated conductors enclosed in a non-metallic sheath. It is suitable for dry locations and must be protected from physical damage. Armored cable, often referred to as AC cable or BX cable, consists of insulated conductors enclosed in a flexible metal armor. AC cable provides better protection against physical damage than NM cable and can be used in both dry and damp locations. Metallic sheath cable, often referred to as MC cable, is similar to AC cable but has a continuous corrugated metal sheath that provides additional protection against physical damage and moisture. MC cable can be used in a wider range of applications than AC cable, including direct burial and hazardous locations. Underground feeder cable, often referred to as UF cable, is designed for direct burial in the ground. UF cable consists of insulated conductors enclosed in a moisture-resistant and sunlight-resistant sheath. It is commonly used for underground branch circuits such as those supplying outdoor lighting or detached garages. Service entrance cable, often referred to as SC cable, is used to connect the utility power supply to the main electrical panel in a building. SE cable consists of insulated conductors enclosed in a weatherproof sheath. It must be installed in accordance with the NEC requirements for service entrances. When selecting and installing electrical cables, it's important to consider the ampacity of the conductors. Ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The NEC provides ampacity tables that specify the allowable ampacities for different types and sizes of conductors based on their insulation temperature rating and installation conditions. It's important to choose conductors with an ampacity that is sufficient for the load they will be carrying. Overloading conductors can lead to overheating, insulation breakdown, and fires. Voltage drop is another important consideration when designing electrical circuits. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slowly, and other equipment to malfunction. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it's important to use conductors that are large enough for the length of the circuit and the amount of current it will be carrying. Conduit is a protective tubing system used to enclose and protect electrical wiring. Conduit can be made of metal or non-metallic materials and is available in various sizes and types. The NEC specifies the types of conduit that are permitted for different applications. Metal conduit provides excellent protection against physical damage and can also serve as a grounding conductor. Non-metallic conduit is lightweight, corrosion-resistant, and easy to install. Fittings are used to connect conduit sections together and to connect conduit to electrical boxes and equipment. Fittings must be compatible with the type of conduit being used and must provide a secure and watertight connection. Electrical boxes are used to enclose electrical connections and protect them from physical damage and environmental factors. Electrical boxes can be made of metal or non-metallic materials and are available in various sizes and shapes. The NEC specifies the minimum size and type of electrical box that is required for different applications based on the number and size of conductors and devices that will be installed in the box. Wiring devices, such as switches, receptacles, and lighting fixtures, are used to control and distribute electrical power. Wiring devices must be listed by a recognized testing laboratory such as Underwriters Laboratories, often abbreviated as UL, and must be installed in accordance with the manufacturer's instructions and the NEC requirements. It's important to choose wiring devices that are rated for the voltage and current of the circuit they will be connected to. Ground fault circuit interrupters, often abbreviated as GFCIs, are designed to protect people from electric shock by monitoring the current flowing in a circuit. If a ground fault is detected, the GFCI will quickly trip the circuit and energize it, preventing a potentially fatal electric shock. The NEC requires GFCIs to be installed in certain locations such as bathrooms, kitchens, and outdoor areas where there is a high risk of electric shock. Arc fault circuit interrupters, often abbreviated as AFCIs, are designed to protect against electrical fires by detecting arc faults in a circuit. Arc faults are dangerous electrical discharges that can occur when insulation breaks down or connections become loose. The NEC requires AFCIs to be installed in certain locations, such as bedrooms and living rooms, to protect against the risk of electrical fires. Surge protective devices, often abbreviated as SPD, are designed to protect electrical equipment from voltage surges caused by lightning strikes, power outages, or other electrical disturbances. SPD divert the surge current away from the equipment and protect it from damage. The NEC recommends installing SPD at the service entrance and at sensitive electronic equipment. When working with electrical systems, it's important to be aware of the hazards of electricity and to take precautions to protect yourself from electric shock, burns, and other injuries. Always to energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician to do the work for you. Understanding electrical drawings and diagrams is essential for designing, installing, and maintaining electrical systems. Electrical drawings and diagrams use symbols and notations to represent electrical components and circuits. A single-line diagram is a simplified representation of an electrical system that shows the major components and their interconnections. A wiring diagram is a more detailed representation of an electrical system that shows the exact wiring connections between components. A schematic diagram is a representation of an electrical circuit that shows the function of each component and how they are connected together. Electrical symbols are used to represent electrical components such as switches, receptacles, lighting fixtures, and circuit breakers. Each symbol has a specific meaning and is used consistently throughout electrical drawings and diagrams. Common electrical symbols include those for single-pole switches, three-way switches, duplex receptacles, incandescent lamps, fluorescent lamps, and circuit breakers. Electrical notations are used to provide additional information about electrical components and circuits, such as voltage, amperage, wire size, and conduit size. The electrical notations are typically written next to the symbols or lines on the drawing or diagram. Understanding the NEC requirements for electrical installations is essential for ensuring the safety and compliance of electrical systems. The NEC is updated every 3 years, and it's important to stay current with the latest edition. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. To ensure compliance with the NEC, it's important to consult the codebook and to work with a qualified and licensed electrician. When performing electrical work, it's important to use the proper tools and equipment. Electrical tools are designed to be safe and effective for working with electrical systems. Common electrical tools include wire strippers, pliers, screwdrivers, voltage testers, and multimeters. Wire strippers are used to remove the insulation from electrical wires without damaging the conductors. Pliers are used to grip, bend, and cut electrical wires. Screwdrivers are used to tighten and loosen screws in electrical boxes and equipment. Voltage testers are used to verify that a circuit is energized before working on it. Multimeters are used to measure voltage, current, and resistance in electrical circuits. Maintaining electrical systems is essential for ensuring their safety and reliability. Electrical systems should be inspected regularly for signs of damage or wear. Loose connections, damaged wiring, and corroded components should be repaired or replaced promptly. Overcurrent protective devices should be tested periodically to ensure that they are functioning properly. Grounding systems should be inspected to ensure that they are providing a low impedance path for fault currents. By following these maintenance procedures, you can help prevent electrical hazards and extend the life of your electrical system. If you are not qualified to perform electrical maintenance, hire a licensed electrician to do the work for you. When troubleshooting electrical problems, it's important to follow a systematic approach. Start by identifying the symptoms of the problem and gathering information about the circuit or equipment that is affected. Use a voltage tester or multimeter to check for voltage, current, and continuity in the circuit. Consult electrical drawings and diagrams to understand the circuit and identify potential causes of the problem. Once you have identified the likely cause of the problem, you can begin to repair it. Be sure to energize the circuit before working on it and follow safe work practices. If you are not qualified to troubleshoot electrical problems, hire a licensed electrician to do the work for you. In summary, using TC cable requires strict adherence to manufacturer specifications, relevant UL standards, and the National Electrical Code, particularly Article 392 regarding cable trays, Article 336 for specific TC cable requirements, and Chapter 3 for general wiring methods, depending on the application. Installers must have a deep understanding of these requirements to ensure safety and regulatory compliance.